I've already touched on this briefly, but we here in North America and globally are seeing a dramatic increase in power, especially where has this been seen the most is in areas of the United States where power increase and power demand specifically for powering data centers has dramatically increased. The numbers and announcements seem to get bigger, and the number of announcements seem to get bigger on a daily basis. But here's the number one question. Why aren't they just simply connecting to the grid? That is how we have approached data centers to date. Why are we suddenly talking about behind the meter generation? And the reason why typically people get grid connected is because it has a high reliability. The grid has extreme capabilities to handle load volatility. Though it doesn't like it, it does have the ability to handle incredible load ramp rates and load volatility. It has traditionally been the cheapest power and also typically has the lowest grid intensity, which is a phrase that we'll use in reference to sustainability, which is the reference to the amount of carbon dioxide that's produced per megawatt hour. So what's the problem? The problem, first of all, is that you might have enough power generation. You might have enough supply like we do here in Alberta, but the ability to get the power to the locations where the data centers want to develop is limited. We have wires congestion. There's other jurisdictions where there just is not enough generation. So you might have enough cables or enough capacity, but you just don't have enough generation. And these two issues create a demand versus supply problem, which has dramatically increased power prices to the point where certain geographies no longer are economic for data centers to locate. I want to speak also to just generally how data centers go about locating their data centers. And let's be honest here. Traditionally, power and power supply has not been the determining factor for where a data center is located. Most of them need to have low latency and be close to where the actual demand is for that data center. So typically, we were focusing most importantly on the ideal geographic location and ensuring that the power that's being utilized within the data center is at an economically viable price. However, this has led to issues about getting timely grid connectivity, where if it is available, we're going to, obviously, that's the preferred scenario, and there's going to be a backup UPS and backup generation solution. Why is this again? Because we have high reliability, high ramp rate resilience, it's cost effective, and it's typically the most sustainable power. In scenarios though where the grid is no longer available, there's options where is it partially available, where maybe you can get 20, 30% of your power, where we can have some sort of hybrid solution between grid connect and a behind the meter solution, or there may just not be availability. And so we're looking at a full behind the meter solution. The question, however, is what's the reliability of that solution? What is the ramp rate resilience? What is the timing of that power? How cost effective is it? Space required, and how sustainable is it? And finally, for reference and just for background on this, for this presentation, this is typically how a data center is connected. So you have a grid connect, the power comes in through a UPS. You have unconditioned power where the power itself needs to be conditioned in some regard. Maybe there's voltage concerns or frequency issues. And the UPS is making sure that the power that is being delivered to the data center is conditioned with a backup diesel system. I want to highlight the dynamic UPS that Rolls-Royce provides, the Kinetic Power Pack, which can combine these two items together for a very space conscious, space efficient, and cost effective alternative. And my colleague Gordon is the right guy for you to talk to if you want to hear more about the KPP. Now,